Good afternoon everyone, and welcome to another worked exam answer video. Today I'm having a look at a back titration kind of question, but in a bit of a different context. So we've got an organic component to this as well, but there are a lot of steps that are the same in terms of how we would approach any back titration question, and that's what we're doing in part B of this question. We've also got a question about percentage uncertainty to start with as well, and this I think is a particularly tricky one to get your head around because of the different context that we've got here. So we are dealing with a sample of olive oil, and it says that this sample of olive oil is mainly the unsaturated fat Y mixed with a small amount of inert impurity. So whatever the impurity is, it is not going to react with the bromine water that we're going to be using, as you'll see in a second. The structure of Y in the olive oil is shown. So this is Y, this is the bit that's going to react with the bromine, but that is not everything that is in the olive oil. And I think having done this question, my head took a little while to figure out what was what here. So we're trying to work out the amount of Y, so this structure here, the unsaturated fat, and we do that by measuring how much bromine water is decolorized by a sample of the oil using this method. So we've got to transfer a weighed sample of oil into a 250 centimetre cube volumetric flask, and we make it up to the mark with an inert organic solvent, inert again, so that that isn't going to then react with the bromine. We're then going to titrate 25 centimetre cube samples of the olive oil solution that contains Y with this concentration of bromine. Now it says a suitable target titer for the titration is 30 centimetres cubed of the 0.025 mole per decimetre cubed bromine water solution. We have to justify why a much smaller target titer would not be appropriate, and then we have to calculate the amount in moles of bromine in the target titer. So when we're thinking about percentage uncertainty, which is exactly why a much smaller titer would not be appropriate here, we've got to think about, or we've got to be aware of how percentage uncertainty is measured. So we do the absolute error on the piece of equipment, so presumably that's going to be going in our burette. We've worked out that our mean titer is going to be 30.0 centimetres cubed. We would then need to do the absolute error on the burette, which is plus or minus 0.15, divide that by 30 times by 100. Now, because the value that we measure is on the bottom of that fraction, the smaller the titer, the bigger the percentage error is going to be. And that just means that we are not going to be able to say with a great degree of certainty that that is the exact volume that we've measured. So a much smaller target titer would result in a much larger percentage error. And sometimes they'll ask that question in a different way. Sometimes they'll say, what can we do in the experiment to give us a lower percentage error? And if you want a lower percentage error, you've got to have a larger either volume of solution, if that's what we're thinking about, a larger volume of solution being measured, or if we're thinking about thermometers, we need to measure a greater temperature change, or if we're thinking about balances, we need to measure a greater mass change, and then thinking about how you can get that in your particular experiment. So smaller values that you're measuring will lead to bigger percentage errors. So that's the first thing. Then it says calculate the amount in moles of bromine in the target titer. So moles is always concentration times volume. The concentration is 0.025, and the volume, which we need to convert into decimeters cubed, will be 0.03 decimeters cubed, and that gives me a value for the moles of 7.5 times 10 to the minus 4. So a nice straightforward start to our calculation there. We've now got the moles of bromine within our target titer. Now what we're trying to do in this question is we're trying to calculate a suitable mass of olive oil to transfer to the volumetric flask using the answer that we've just worked out in part A and the structure of Y that we've got given above. And up here we have been given the MR of that, which is particularly nice of them. I wouldn't want to have to work that out, although they did give us the molecular formula, I suppose. And then it says, assume that the olive oil contains 85% of Y by mass. So this saturated fat makes up 85% of the olive oil. The inert impurity makes up 15% of the olive oil. So this is where the back titration comes in. So we have been given the concentration and volume of one of the substances involved in that titration, and we've got the moles of the bromine as 7.5 times 10 to the minus 4. Now what we need to do is have a look at the structure of Y to be able to figure out what the ratio is between the bromine water and Y, the unsaturated fat Y. Now we don't need to write it as a balanced chemical equation, and that is how, for example, in an acid and alkali titration, you'd have a balanced chemical equation, you'd use the number of moles of acid and alkali to get your ratio. You'd use the balancing numbers. Here, if we're using bromine water and we're looking at the bromine water being decolorized, we need to connect bromine water being decolorized to double bonds. And then once we've kind of got our head around that, we then need to work out, well, how many double bonds do we need to decolorize? And the answer to that is 1, 2, 3, 4, 5. So the ratio of Y to bromine is going to be 1 lot of Y is going to require 5 moles of bromine. So that's the first thing we're going to need to do. So I'm going to write it like that. And then that ratio is going to be 1 fat. We're going to need 5 lots of bromine. So if we then know the moles of the bromine, which we do because we just worked that out, so that value there is 7.5 times 10 to the minus 4, then we would be wanting to divide that by 5 to get the moles of Y, which is equal to 1.5 times 10 to the minus 4 moles of Y. Now that was in the 25 centimetre cubed sample that we titrated against the bromine. So there are that many moles in 25 centimetre cubed. Now this is incredibly common for back titrations because in each titration we will be using a fraction of what is in the volumetric flask. So we now know how many moles were in the 25 centimetre cubed titer, the 25 centimetre cubed sample that got us the titer for the bromine, but we want to know how many moles there are in the 250 centimetres cubed that were in the volumetric flask. So we have to scale up our moles. So to get to 250 centimetres cubed, we're going to need to times the volume by 10, so we're going to need to times the moles by 10. So we're going to have 1.5 times 10 to the minus 3 moles in 250 centimetres cubed. Now that we've got the moles, we can think about the mass of just Y that is needed to give us that many moles in 250 centimetres cubed of solution, and this is where the MR comes in handy from up here. So once we've got moles, we can get mass, so mass is equal to MR times moles. So mass is equal to 880 times 1.5 times 10 to the minus 3. So the mass of Y is 1.32 grams. Now this is the bit that I needed a moment to get my head around. In the olive oil, we have the unsaturated fat Y and an inert impurity. Now that inert impurity will not be reacting in this titration. So the only part of the olive oil that is reacting with the bromine is Y. So the amount of bromine that we added is the amount of bromine needed to react only with Y, not the whole of the olive oil. So this is then the moles of just Y within the olive oil, and this is the MR of just Y in the olive oil. So the final key thing that we need is this bit there. So we've got to assume that the olive oil contains 85% of Y by mass, because we're not trying to figure out how much of Y to put into the volumetric flask. We're trying to calculate the mass of olive oil that needs to go in the flask. So that there is the mass of Y, which is equal to 85% of the mass that I need of the olive oil as a whole. So the final step will be to convert 1.32 grams into 100%. Now, there's a few ways we can do that. I'm very much an old school kind of, I'm going to divide by 85 to get 1%, and then I'm going to times by 100 to get 100%. And that gives me 1.55 grams. And that is then the mass of the olive oil, which will include the inert impurity that did not react in our titration. And with our standard back titration questions, you will do the same sort of thing. You will get the moles of the thing that you can, in this case the bromine, use the ratio to get the moles of the thing that you want to find something out about, so Y in this case, so that we could get about the olive oil. Then look to see if there's a scaling, which there will be if we're making up a solution into a volumetric flask, so make sure you scale your moles. And then this is the end bit, is where it changes. We might get an MR and ask to get a mass. We might get a mass and have to work out an MR. We might have to do a percentage by mass or a percentage purity. The percentage purity here, we could do 1.32 divided by 1.55, because that will tell us, well, that would give us our 85%, wouldn't it? So we've kind of got the percentage purity here, 85%. But if we knew the overall mass, we could then get this mass divided by the total mass to get the percentage, once we've timed it by 100. Or here we've done something slightly different. We've kind of worked backwards using the percentage purity to figure out the overall mass that we needed to add to the volumetric flask in the first place. So that's a not particularly nice question, partly I think because there's just a lot going on, partly because we've got the olive oil and we've got Y, and they're not the same thing. Y is just a component in the olive oil. And then this end part of the back titration calculation is not what we're used to doing. We usually just work out a mass, or you work out an MR. Fine. This time there was that extra step we had to do. As always, if anything I've said there is unclear, please do not hesitate to ask, or if you've got other back titration questions that you want me to have a look at and do a video on, as always, please just send them over to me. My email address is in my YouTube comments, or it's Miss G Tutoring and Resources at outlook.com. Thanks so much for watching, guys. Take care.